Our solar system might have some more planets up its sleeve. We know about 8 official planets, but they're not the only ones that survived the chaotic formation of our solar system 4.5 billion years ago. Astronomers say there are 3 categories of planets in our solar system. We're in the first one, the 4 rocky inner planets: Mercury, Venus, Earth, Mars, that peacefully orbit the Sun. They're located within the main asteroid belt that separates Mars from Jupiter, which is in category number 2. That one's a group of planets in the outer solar system, the gas giants: Jupiter, Saturn, Uranus, Neptune. These planets have huge amounts of ice and gas around what scientists believe to be their rocky cores. The third group lies beyond the area where our local planets are, somewhere further than Neptune. It's the realm where you'll find dwarf planets such as Pluto, Eris, and Sedna, and many smaller space bodies like comets. But new findings say there could be something else lurking in the dark, besides dwarf planets and tiny space bodies, maybe even a new planet. Models scientists made say that our outer solar system used to have 1 or more rocky planets, the size of Mars or Earth. Over time, these rocky wanderers interacted with the wide gravity fields of our gas giants. This kicked them into a far-out orbit, away from the neighborhood. The question is if one of those Mars-sized planets survived and could really be somewhere out there. Scientists have made simulations to see what potentially happened. These showed that in half of such cases, where planets interact with the gravity of gas giants, they get ejected into interstellar space. In the remaining half, there's this one rogue planet, left in an orbit similar to ones the Kuiper Belt objects are following. There's only one thing left to do now: find it. Astronomers found the loneliest planet in the universe. They were trying to find distant brown dwarf stars, or failed stars, ones that never become massive enough to start shining. Stars are born with big masses, which means they also have strong self-gravity. The star squeezes in on itself. That causes high internal temperatures and enables the star to shine. But instead, they found a lonely wanderer, CFB DSIR 49. The planet is between 50 and 120 million years old and has a surface temperature of 750 degrees. Compared to stars, that's cold. At first, scientists thought it could be a brown dwarf star, but in that case, it would be way older. This starless planet floats around through space, passing only 130 light years away from our planet. Our galaxy, the Milky Way, is 100,000 light years wide, so that's relatively close. The Lonely Traveler is actually a gas giant, 4 to 7 times bigger than Jupiter. Maybe it was kicked out from its own solar system because of gravitational forces, or getting into another planet's orbit, or it was formed away from its parent star. Far beyond Pluto, on the edge of our solar system, there's a space body about as big as Pluto, but a little bit colder and way denser. It's probably a big rocky body covered in a thin icy mantle. It's the dwarf planet Eris. Both Pluto and Eris occupy the Kuiper Belt, which is the distant ring of frigid space bodies that lies beyond Neptune. A day there lasts 25.9 hours, pretty similar to Earth. But Eris circles our sun in the distance 3 times farther than Pluto, which means its year is pretty long, 557 Earth years. Eris has a bright, icy surface. It's one of the most reflective bodies in our solar system. It bounces back more than 95% of the light that strikes it. Somewhere out there, even farther, there's a super Saturn, J-7b, much larger than Jupiter or Saturn. It's an exoplanet, which means a planet that orbits a star other than our sun. Super Saturn is 434 light years away from Earth, constellation of Centaurus. It's the only exoplanet we know about with rings similar to Saturn. It actually has a huge ring system, 200 times bigger than Saturn's rings. There are more than 30 rings, each of them tens of millions of miles in diameter. There are gaps in the rings, which means there could be some interesting satellites, exomoons, around. If this super Saturn could swap places with our regular Saturn, its rings would absolutely dominate our sky. You could look up and easily see them. The view would be amazing because they would appear much bigger than a full moon. Scientists have found thousands of planets outside of our solar system. Some are dense as iron, while others are airy and light. And then there's the water world, GJ 1214b, a steamy world bigger than Earth and smaller than Uranus, 40 light-years away from us. Constellation of Ophiuchus. It's a watery planet surrounded by a thick atmosphere, 2.7 times Earth's diameter, and almost 7 times heavier than our home planet. It was most likely formed somewhere farther from its star, where there was plenty of water ice, but later migrated to where it is today. Its surface temperature is 440 degrees, which is too hot to host life like on Earth. It also has much less rock and much more water than our planet. Imagine a planet with no land, but only endless oceans covering all of its surface. High pressures and temperatures would form things like superfluid water or hot ice, some pretty exotic materials that we can't see on our planet. Gliese 436b. It's a Neptune-sized exoplanet, 30 light-years away from our planet, constellation of Leo. It makes one full orbit around its star in a little more than 2 days. This planet defies the laws of physics. It orbits its star, Gliese 436, which is smaller, cooler, and less luminous than our Sun, at a distance 15 times closer than Mercury is to the Sun. When we typically think of ice, we picture a frozen cube, even though the temperature there is 980 degrees. This temperature is way above the melting point, but the ice remains solid and burning hot. This happens because of very strong gravity. It compresses the water vapor in the atmosphere into solid ice. The pressure here doesn't allow the ice to melt, no matter how hot the surface is. Now imagine being on a mysterious planet and it suddenly starts raining sapphires and rubies. One distant exoplanet, HAT P7b, a gas giant 1,000 light-years away from Earth in the constellation of Cygnus and 16 times bigger, has specific weather with pretty violent storms. Rubies and sapphires are scattered across the planet when it's raining. On the planet's night side, there's a high amount of corundum in the atmosphere. And corundum is what mineral gems such as sapphires and rubies are made of. Clouds of corundum give such an amazing view. The planet is plagued by severe winds that often turn into powerful storms that push huge masses of those clouds across the planet. Although the planet is uninhabitable, it would certainly be cool to come there and pick up some gems. Still, the weather is pretty wild. Plus, the temperatures are over 4,600 degrees. By comparison, Venus is the hottest planet in our solar system, and its temperature is only 900. Looking over the expanse of space, you can see a beautiful little blue dot in the endless darkness. It's an exoplanet, HD 189733b, that lies 63 light-years from us in the constellation of Vulpecula. But it's way hotter and larger than our planet, around the size of Jupiter, and completes the orbit around its host star in only 2.2 Earth days. That orbit is so close that the planet is most likely tidally locked. That means it's always showing only one face to its star, like our moon always shows one side to Earth. The weather here is crazy, which is 7 times the speed of sound. The fastest wind on Earth only hit the mark of 230, and it gets better. The rain here is not made of water, but of molten glass. Clouds are made of silicate atoms and particles. They are the key element that gives the planet its cobalt blue color, not the reflection of oceans, which is the case with Earth. Earth used to be purple. Today, even when you look at our planet from space, you see a lot of green. The green we see in nature is there because of photosynthesis, the process where plants transform energy coming from the sun into energy they need to live and to produce oxygen. The main part of the process that gives plants the green color is the chlorophyll pigment. A long time ago, instead of chlorophyll, there was a molecule called retinol. Its pigments absorb yellow and green light and turn it into red and blue, so the Earth was more purple. And then there's a pink planet, GJ 504b, far away from us. Virgo constellation, 4 times more massive than Jupiter. It's a newly formed exoplanet, around 160 million years old. For comparison, the Earth is 4.5 billion years old. If we could go there, we would see an incredible world that glows from the heat of its formation. Everything around you would be colored magenta. Is there a giant megasun in the center of our Milky Way? Scientists actually thought so for a while because it's the brightest place in the galaxy. It has millions of stars packed into a small area. This area is called the Galactic bulge. The Galactic bulge has millions more stars per a light year than any other part of the galaxy. It can be 10 million times denser than our part of the neighborhood. In some cases, stars in this region are only 5 light days apart. That's like if there was another star in our solar system a bit farther away than Pluto on a space scale. But why is this place so dense? When galaxies form, a lot of gas and dust come together under the force of gravity. This material gathers up and eventually forms stars. Gravity and angular momentum balance out, and it starts looking like a flat disk with a pretty bright, bulging, dense core. The stars live their comfy lives, and once they get to the finishing line, they collapse under their own huge weight. Then, the black hole forms. Black holes love to eat everything around them, and the more they eat, the bigger they get. And what place is more perfect for fine dinner than the galaxy center, where all the space stuff is packed together? So it starts eating surrounding gas and dust, forming an accretion disk. As this material spirals into the black hole, it heats up and emits a lot of energy, which makes the center of the galaxy even brighter. That's why you can find both supermassive black holes and galactic bulges in the centers of all galaxies. The galactic bulge at the center of the Milky Way looks a bit like an ellipse. That's a classical bulge. Stars there aren't like our sun. They move randomly in all possible directions and planes. Plus, they all move at different speeds. So gravity is going crazy there, and this makes the bulge look more like a sphere or an ellipse. Since they were the first ones to form, they have some of the most ancient stars in our galaxy. But there are also some places of star formations and lots of younger massive stars that are less than 100 million years old. As we move farther away from the center, things get a bit calmer. Stars start rotating uniformly and become stable. Right now, Earth is in one of the Milky Way's spiral arms called the Orion arm, pretty far away from the galactic bulge. In our part of the neighborhood, stars are usually about 4 or 5 light years apart. This means that most of a galaxy is actually just black, empty space. Our black hole is called Sagittarius A star. It's a monster about 4 million times the mass of our Sun. It's also about 51 million kilometers in size, almost like the distance between Mercury and the Sun. But don't worry, it's not attracting the Milky Way inside it, and it's not going to eat us. These black holes are actually super small compared to the entire galaxy, so they can only eat whatever is around. Right now, many stars orbit Sagittarius A star, and even though it emits a huge amount of energy, we can't see its light from Earth without a lot of scientific effort. But why don't we see the center itself? The galactic bulge is so bright that even though it's 26,000 light years away, we should see it shining brightly in our sky. Yet we don't. Turns out it's all because of space dust. There is a lot of dust between us and the core, and it absorbs most of the visible light. We can only look at the galactic core using other types of light, like near-infrared, gamma ray, and so on. NASA has images of the core in different types of light, and it shows how scarily bright the center is without the dust blocking our view. But not all bright regions are blocked by gas and dust. For example, when we look at dense clusters like the Messier 13, the stars are so close together that they look just like a white spot. Most of our telescopes can't separate them from each other. The satellite galaxy M32, our neighbor near the Andromeda galaxy, has about 84 stars per light year. It's so dense that stars can't be resolved even by the Hubble Space Telescope. To get the idea, our solar system is 2 light years long. We'd see about 168 stars outside our window if we were there. Our closest star is Alpha Centauri. It's about 4 light years away from the Sun. If it was just a couple of light days away, it would shine much brighter than the full moon. So if we somehow managed to survive in crazily dense star regions, the sky would be white all day long. But it's unlikely that we'd make it. As we get closer to the center of the Milky Way, the chances of finding life get super slim. The gravity of stars is going wild with chaotic movements, so there are barely any planets around. On those miracle planets, the radiation from cosmic rays is skyrocketing. Supernova blasts and star collisions nearby become an everyday occasion, and all the gas around makes it basically impossible to breathe or even see properly. At the same time, as we move farther away, there are fewer stars around. Elements that are super useful for life, like carbon, oxygen, and iron, are produced by stars, so they also drop. Too much radiation is awful, but too low radiation means that there's not enough energy to support chemical reactions like photosynthesis, which is why, if there's extraterrestrial life, it would most likely be somewhere in the middle of different galaxies. But some galaxies get their brightness from a so-called active galactic nucleus. These are extremely energetic regions at the center of some galaxies. They shine much brighter than any stars imaginable, although it mostly shines only in certain parts of the electromagnetic spectrum. The brightness comes not from the stars, but from the accretion disk around their supermassive black holes. As the material slowly falls into a black hole, it gathers around it and creates this flat, spinning disk of gas, dust, and other stuff. Since the gravity and friction there are insane, this disk heats up and starts emitting enormous amounts of energy. Also, this disk spins incredibly fast, almost at the speed of light. Because of that, collisions there happen all the time, and they're unimaginably powerful. They release even bigger amounts of energy. Most galaxies don't have an AGN. Those that do, like the galaxy M87 in the Virgo constellation, are called active galaxies. There are also different types of AGNs, like Seyfert galaxies, radio galaxies, and finally, the winners of our space brightness competition, quasars. Imagine things so bright that they can outshine the entire galaxy they belong to. Quasars are a specific type of active galactic nucleus, the most extreme and luminous form. They belong to the supermassive black holes, the biggest ones in our universe. Quasars are like a combination of several things. First, they're the brightest accretion disks in our world, because of their behemoth black holes eating everything around. But they have some cool features. For example, they have powerful jets of particles that shoot out from the poles of the black hole at nearly the speed of light. These jets add up to the brightness of the quasar, although they can only be seen in radio wavelengths. The energy they emit is so intense that they can be seen billions of light years away. However, the nearest quasar to us is 600 million light years away, so we can't see them with backyard telescopes. So, when we look at a galaxy through a telescope, we usually see only the brighter core, not the outer parts. Unfortunately, our eyes just aren't made to see things like the active galactic nucleus, so these stars are the brightest things we can see. But what a beautiful sight it is. In May 2024, stunning auroras adorning the night sky demonstrated all the power that solar storms emit as radiation, but sometimes our sun does things that are far more destructive. I'm talking about solar particle events. During these events, blasts of protons coming directly from the surface of the sun can shoot out like giant cosmic searchlights. According to records, an extreme particle event hits Earth every 1,000 years or so. It often causes bad damage to the ozone layer and increases levels of ultraviolet radiation closer to the surface of our planet. Luckily, Earth's magnetic field acts as a powerful protective cocoon for our planet, fending off electrically charged radiation from the sun. In its normal state, this field functions like a ginormous bar magnet, with field lines rising from one pole, looping around the planet and dropping at the other pole. This pattern is sometimes called an inverted grapefruit. This vertical orientation of the magnetic field at the poles allows some ionizing cosmic radiation to get through the field as far down as the upper atmosphere. There, It interacts with gas molecules and produces the glow we know as auroras. But over time, Earth's protective bubble changes. In the past century, the North Magnetic Pole moved across northern Canada at a speed of about 40 kilometers per year. Plus, it weakened by more than 6%. Even more shockingly, according to geological records, there have been periods of time, as long as centuries and millennia, when our planet's magnetic field was super weak or entirely absent. But we'll talk about those tragic times later. It's easy to imagine what our planet would look like without its protective bubble if you look at Mars. The red planet lost its global magnetic field long ago. And once this field disappeared, most of Mars's atmosphere vanished too. In May 2024, a strong solar particle event hit the planet. It disrupted the operation of the Mars Odyssey spacecraft and made radiation levels at the surface of the red planet rise around 30 times higher than what a person receives during a chest X-ray. The sun's outer atmosphere constantly emits a changing stream of electrons and protons, the solar wind. At the same time, the surface of the star also produces bursts of energy, mostly protons, during solar particle events. These bursts of energy have a connection to solar flares, extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. Protons are way heavier than electrons and carry more energy. That's why they can reach lower levels of Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit X-rays invisible to the unaided eye. Dozens and hundreds of relatively weak solar particle events happen during every solar cycle. Now, let's speak about solar cycles for a minute. You see, from a distance, the sun seems to be calm and steady. But if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole and vice versa. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period has the name of solar maximum. It's a rather dangerous time for Earth since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Anyway, back to our solar particle events. Researchers have found traces of extremely strong solar events happening throughout the history of Earth, and some of them were thousands of times stronger than anything our modern instruments have ever recorded. Such extreme solar particle events happen approximately every few millennia. The most recent one occurred around 993 CE. Beyond the immediate effect they have, solar particle events can kickstart a chain of chemical reactions in the upper atmosphere, and these processes often lead to depletion of ozone, which isn't a good thing. Ozone absorbs harmful solar UV radiation, which can damage not only our eyesight, but also the DNA of living beings. Plus, changing the amounts of ozone in the atmosphere can impact the climate. In a recent study, researchers used large computer models to examine how extreme solar particle events affect Earth. They found out that if a solar proton event arrives during a period of time when our planet's magnetic field is very weak, then ozone damage can last for 6 years. And the level of UV radiation might increase by 25%, boosting solar-induced DNA damage by around 50%. And apparently, this dramatic combination of a weak magnetic field and extreme solar proton events happens quite often. And some researchers believe that it may even explain a few mysterious occurrences in the past of our planet. For example, the most recent period of weak magnetic field started 42,000 years ago and lasted for around 1,000 years. This period included a temporary switch in the North and South poles. Several major evolutionary events happened during that time. For example, the last Neanderthals disappeared in Europe, along with the extinction of marsupial megafauna in Australia. Yeah, sadly, we won't see giant wombats and giant kangaroos anymore. One more, even bigger evolutionary event might also be linked to Earth's geomagnetic field. Multicellular animals appeared at the end of the Ediacaran period, which started around 635 million years ago, and it occurred after a 26 million year period of extremely weak or even absent magnetic field. The rapid evolution of different groups of animals in the Cambrian explosion about 539 million years ago might have also been related to high UV levels and geomagnetism. The simultaneous evolution of hard body shells and eyes in multiple unrelated groups could have been necessary to detect and avoid harmful incoming UV rays. A complete reversal of Earth's magnetic poles might have a serious impact on the climate of our planet. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. That's why the magnetosphere continues protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Our planet's magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges, called electrons, moving through the metal. The current is what generates a magnetic field. Earth's outer core is made of liquid iron and nickel. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving throughout the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the Magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic ray radiation, which, otherwise, would be extremely hazardous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. History teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word, Pangea, which means all the Earth. Pangea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea stretching between the tippy top and bottom of our planet. But, as stories go, things changed. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakup party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other. and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Just look at the shapes of today's continents. You notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by water for years. But even so, we still can see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learned their history and what species there were. But when scientists compared fossils found on different continents, they noticed something interesting. These fossils looked similar. Surprisingly, they belonged to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their 4 paws, and it's unlikely that this particular type of animal originated in 2 places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at all these things together, you get a pretty clear picture. The Earth's continents were once huddled up together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were 2 original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figured out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Arica, and Amasia. These might sound like superhero names, but they're actually different ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up, while the Pacific squeezes in. If that happens, the Americas, North America, and South America will give each other a big high five, and Antarctica, that icy land way down south, will join the fun too. It will be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So, if these secret tunnels will be spreading and spreading all along the east coasts of the Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas. And boom, Orica. And finally, a Masia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents, except Antarctica, might come together. And even though they might gather around the North Pole, they wouldn't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. Keep asking curious questions and stay tuned for the next 100 million years. Ah, well-deserved vacay. Finally. This time, you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus moon's oceans, let's talk about Uranus itself first. The 7th planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet, and that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups, 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon, and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my! These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too, and because of that tilt, they have crazy seasonal cycles, just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit, they're likely captured asteroids that could be rocky or icy or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon, with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half ice, half rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons, with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features, but one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These 2 shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces. And the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now, you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited, these oceans are pretty salty, about 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's fifth biggest moon, Miranda, well, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe. UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore. It's a clear night, and you are outside looking at the stars. The Milky Way alone seems overwhelmingly huge. You check on your phone and discover that the galaxy you're in at this exact moment is 100,000 light-years wide. For scale, 1 light-year is already a very long distance. For example, it takes 4.2 light-years to go from Earth to Proxima Centauri, which is the closest star to our planet other than the Sun. So 100,000 light-years is way more than we normal humans can fathom. And that's just one galaxy. There's a whole lot more out there. Now, looking at this data, it seems pretty unlikely that we're the only life form out there, doesn't it? But how come we've never found anything else so far? Let's get one thing out of the way. Extraterrestrial life doesn't necessarily mean we're talking about little green people. It can also mean microorganisms, bacteria, and plants that can be found on other planets. The truth is, there is a big spectrum of possibilities for life on another planet, and taking into consideration that there are up to 50 billion planets in the Milky Way, it's very unlikely that we are alone in this big wide universe. And what does life on other planets look like? This is what we've spent years trying to figure out. Go ahead, think with me. A planet may be lifeless today, but it could have traces of organic matter or fossils, meaning that some life form was able to thrive there once. And it could also be that there are planets out there containing life with complex biochemistry, meaning they could have fauna just like we have on Earth, although probably not the same. NASA created a special science that is dedicated to studying life forms outside of Earth. It's called astrobiology. Ever since the space agency was created back in 1958, it didn't take long for it to start looking for extraterrestrial life. They quickly built an action plan. First, they needed to understand how life on Earth was formed, and secondly, how it could have formed on other planets. The first time NASA tried to look for life in outer space was in 1976. The Viking lander blasted into space headed toward Mars. There were high expectations that humanity would find the first proof of extraterrestrial life. Unfortunately, the lander came back with images of a planet that looked barren and bleak, and scientists were extremely disappointed. Scientific conclusions on whether life could be detected over there were confusing. But hey, you need to know what you're looking for to find it, right? The failure of the Viking mission served to heat up debates amongst NASA scientists to define what life actually meant. And it also served to call their attention to a small, but very important detail. Spacecrafts departing from Earth usually transport Earthling microorganisms and bacteria unintentionally, as they remain attached to the vehicle. It turned out that these bacteria could contaminate scientists' samples, so they needed to consider this. All of this made Mars expeditions take a back burner on NASA's short-term plans. There appeared a new priority-first question. What are the types and stages of life that space programs can hope to identify? Scientists might have encountered life on other planets, but they weren't able to identify it as life. That is why NASA began to study our own planet better. They studied everything, from ancient life forms that lived billions of years ago to living creatures that roam the planet today. They understood that the search needed to happen inwards as well as outwards. Let's take a look at the development of Earth's life from its inception. Imagine that this development can be represented as a ladder or stairs, and each developmental stage is a flight of the bigger staircase. First, we would see basic chemistry, a soup of loose chemical elements, like the ones we see in the periodic table. but they need to assemble themselves into more complex structures to be able to self-replicate, change, and evolve. This would happen in the second step, where we start to see the formation of microscopic organisms. In the third step, these cells combine to become multicellular beings, allowing for more complexity and variety. The step above sees species that can evolve big brains, enabling the use of tools, culture, and shared knowledge. That's where humanity is located. Looking at this ladder, one might ask, so what does it take for a multicellular organism to evolve into fully formed humans? This is what is called the Great Filter. It's a huge evolutionary jump that takes a lot of effort and the perfect environmental conditions for it to happen. And given that we haven't heard of any other extraterrestrial civilizations out there, it might be that we are the only ones that were able to make this jump. After all, how likely is it that we'll find life outside of Earth that is similar to us? That depends on how many planets there are out there in their star's Goldilocks zone, the area around a star where water can be liquid. And because stars come in all sizes and configurations, this zone is different for every star system. But that's not the only criteria we know for the existence of life. We usually look for three things to detect life: liquid water, methane, and oxygen. Water is what allows for chemical components to mingle and connect, forming multicellular beings. Methane is produced by the decomposition process made by bacteria, and oxygen is the byproduct of plant respiration. These are some of the telltale signs that the James Webb Telescope was programmed to search for. The James Webb Telescope has ambitious purposes that might revolutionize space science. Its top priorities are to detect forms of life by studying small galaxies orbiting the Milky Way. It will also look for the oldest stars in the universe, trying to gather data on the origin of the universe itself. That's huge. NASA is betting on two variables with this new telescope: a thorough scan on the so-called exoplanets, aka planets from outside our solar system, and the search for extremophiles, a type of life that loves extreme environments. Extremophiles were first discovered on planet Earth back in the 1960s at the bottom of the sea, near the Galapagos Islands. Scientists found microorganisms living next to hydrothermal vents that dot the seafloor over that part of the world. Thriving in places like these with extreme temperatures over 700 Bajert F takes a lot of resistance. I mean, can you imagine the heat? This discovery was a turning point for the field of astrobiology, as scientists understood that life could survive in extremely harsh conditions, similar to the atmosphere available in several exoplanets. But hey, life might turn up in our own neighborhood if we're lucky enough. Guided by the mantra, "Follow the water," NASA is launching two important missions inside our solar system that can contribute largely to the search for extraterrestrial life. You remember Jupiter, right? It's the gas giant that has a moon known as Europa. A few years ago, scientists discovered that Europa had an ocean hidden behind layers of icy crust. And there's even more. According to research, the water over in Europa is salty, much like the water we have on our planet. Europa is a big contender for the detection of life, but the Europa Clipper mission is not aimed at trying to identify this. Rather, it will orbit the moon and gather as much information about its atmospheric conditions as it can. The other moonbound mission is the Dragonfly, an octocopter that will explore Saturn's moon, Titan. The launch is programmed for 2027 and will only arrive in Titan's orbit around 2034. It will sample and examine a series of promising sites around Saturn's icy moon, and who knows, find some new information on ET life? Let's see what happens. But I'd say we've never been closer to a huge discovery than we are now. Imagine a black hole, a terrifyingly dense space object, pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine two of these space monsters colliding. Scary? You bet! Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noticed that two gigantic black holes were growing alongside each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. We can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we are talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists consisting of more than 200 astronomers had been working for years to get this result, and their efforts finally paid off. The object in the photo is about 55 light-years away from Earth, at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet, by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order, with the help of precise atomic clocks set on each telescope. Plus, They were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they are really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light years away from Earth. That's too far for this monster to have any influence on our planet. Besides Sagittarius A, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? You do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops! Bye-bye! Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if one day one of them reaches our planet? If you manage to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes located in different galaxies aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement. The center of the Milky Way is a story of intense radiation, gravity, and mystery. A place where the forces of nature are pushed to their limits. But what if our own planet were to find itself in this cosmic theater? What would happen if the Earth were located there and somehow managed to survive? Let's start this journey to the heart of our galaxy and find out. Picture this. You're floating in space, surrounded by billions and billions of stars. Suddenly, you see a bright, swirling mass of gas and dust in the distance. That, my friend, is the Milky Way galaxy, our home in the vast expanse of the universe. The Milky Way is estimated to contain over 100 billion stars and is about 100,000 light-years across. In other words, if you were traveling at the speed of light, it would take you 100,000 years to cross the Milky Way from one end to the other. It's a couple trillions of miles. And it isn't just a static collection of stars and gas. It's a dynamic, evolving system. In fact, the Milky Way is currently hurtling through space at a speed of about 1.3 million miles per hour. One of the most fascinating things about our galaxy is its shape. The Milky Way is a spiral galaxy, which means that it kinda looks like a disk with a central bulge and spiral arms. The spiral arms are the areas where new stars are born. It's where the most stars, gas, and dust are concentrated. And this is where the solar system is located. Our system is like a tiny speck in the grand cosmic tapestry of the Milky Way. It's about 26,000 light-years away from the center of the galaxy, a pretty long distance, isn't it? The solar system is also moving through the Milky Way as it orbits around the galactic center. It takes about 230 million years for our system to make one complete orbit around the galaxy. Just imagine that. Since the time of the dinosaurs, we've traveled just a quarter of this way. The position of the solar system in the galaxy affects our life in many ways. For example, things like the amount of radiation and cosmic rays we're exposed to, and even the likelihood of asteroid impacts and so on. Also, thanks to our location, we can enjoy some pretty amazing views of the universe around us. From our vantage point in the Milky Way, we're able to see other galaxies, nebulae, and star clusters in breathtaking detail. We're also a part of a pretty happening neighborhood, with lots of other stars and planets nearby, so we're lucky fellows. But what would happen if we weren't so lucky? What if the Earth was located in the center of the Milky Way instead? The center of the Milky Way is home to a region of space called the central bulge. And it's just packed with stars. It's like a disco ball, but instead of shiny mirrors, it's covered in stars. Only this disco ball is really huge, about 10,000 light-years in diameter. The center of the Milky Way is also home to some extreme environments that would make even the bravest astronaut shiver. High-energy particles and intense magnetic fields can wreak havoc on electronics and spacecraft. Intense radiation fields can fry anything in their path, so it's not exactly a friendly place for life as we know it. So, if the Earth were located somewhere closer to the center of the Milky Way galaxy, it would be a very different place. Let's take a look at some of the potential effects. First of all, radiation. As we mentioned earlier, the center of the Milky Way is one of the most radiation-dense regions in the galaxy. It would make life on Earth very challenging, if not impossible. Sure, we have the Earth's magnetic field. It's like a giant shield that protects us from harmful radiation from outer space. But could it protect us if we were located in the center of the Milky Way? Unfortunately, win for the galaxy. But it's not all doom and gloom. There are some brave organisms that are able to adapt to high levels of radiation. We've seen that life on Earth has evolved to survive anywhere, from the depths of the ocean to the icy poles of the planet. So let's imagine what would happen if we somehow evolved to survive in these harsh conditions. Like, picture humans with tough, scaly skin that protects them from radiation and plants with unique structures that allow them to thrive in this bright environment. In that case, radiation still could have some seriously spooky effects on us. For example, it could damage DNA molecules and cause mutations. Imagine a world where plants grow with 5 leaves instead of 4, animals have strangely colored fur, or people have unusual eye colors or other unique features. And these are just some of the best examples. Let's not dive into the bad ones. Also, it could cause us to undergo some metabolic changes. Maybe our bodies could process food and other resources more quickly, which could lead to faster growth rates and larger sizes. Plants could grow tall and thick, and animals would be much larger than usual. There are also some organisms on Earth that are able to bioluminesce. Thanks to high levels of radiation, these organisms could potentially glow even brighter than usual. Imagine walking through a forest at night and seeing trees, mushrooms, and even insects glowing with an eerie blue or green light. Frightening and amazing, isn't it? But let's move on to the next big change, gravity. The gravity in the center of the Milky Way is incredibly strong. all thanks to a supermassive black hole, which is about 4 million times the mass of the Sun. This black hole is called Sagittarius A, and yep, it's our neighbor now. Great. And assuming we don't get swallowed by this black hole or crushed by this incredibly strong gravity, it still could trigger lots of earthquakes and volcanic eruptions. This black hole would be like the gravitational bully, pulling and tugging at everything in its path. Basically, if we survived this, we'd have an epic surfing competition every single day. Just add a bit of thrill of risking your life, and forget about running away from the planet. No easy rocket launches anymore. And physical objects won't be the only ones affected by gravity. Time would flow very differently for us. According to Einstein's theory of relativity, time passes more slowly in areas of high gravity. In other words, Earthlings would age more slowly than someone far away from the center of our galaxy. Also, the center of the Milky Way is a very busy place. Stars, planets, and other celestial objects moving around at incredibly high speeds there every day. The positions of stars and other objects would constantly be changing. In other words, say goodbye to normal navigation. The GPS systems would likely be unreliable due to the strong gravitational forces and high radiation. So if you accidentally got lost in a glow-in-the-dark forest with some creepy animals, good luck. But it's not all bad. The center is also home to molecular clouds. These are the regions of space where new stars are born. And the Milky Way in general has some pretty amazing sights to offer. For example, stunning nebulae like the Orion Nebula and the Eagle Nebula, which are visible with telescopes or even just a good pair of binoculars. So, if Earth were located in the center of the Milky Way, we would have a front row seat to some of the most spectacular cosmic events. Wouldn't that be awesome? Overall, if Earth were located in the center of the Milky Way, it would be a very different place. Of course, we all understand that our planet wouldn't have survived such a change, but it's still pretty interesting to imagine how our life would flow if we were there. And judging by what we just discussed, it wouldn't be pretty. So let's treasure and appreciate our small, quiet solar system. So, Mars has 2 moons, Phobos and Deimos, and apart from the bizarre shape, there's nothing remarkable about them. Except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon? And what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Do you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars, or Ares, is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took their first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its suns, after all. But even though they're very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these 2 satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites. And that's when they discovered a significant difference between the two. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, what's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas. And these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They've learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they could crash into it, jump away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become a part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen. So this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else, something even more powerful. Could it be Mars itself? Theory 3, Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like, once upon a time, they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time, they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange, though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, And because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of the gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30-50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is also called the doomed Martian moon. Anyway, these are all only theories, but the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX, Mars Moon Exploration mission, will reveal some of the most exciting secrets Mars moons are hiding. Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy, and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow! Didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are 2 ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when 2 magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars in the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing! But have you seen the one with 2 blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth, and when that light goes through the Earth's atmosphere, it creates a big blue blob with a convection swau al texture sturdiu. Lain kasentin. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon when it reflects off the Earth and goes through the atmosphere. The blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 F, 11 times 12 F. This may sound hot at first, but for comparison, our sun is about 27 million F. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the Northern Hemisphere are familiar with the star named Vega. First, it's brighter than expected, but if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF 14 Echelles, decided not to obey the rules. It started to fade away, like most other stars. But then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once, it kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago, 1954. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, my Camelopardalis, but when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form, but they've never really seen it happen. The universe is 13.8 billion years old, and from what we can see, one mysterious star, HD 14283, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is. At least 13.2 billion years old, while the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with the tail either. It's called Mira. Sometimes it's bright and other times it's faint, making it a bit of a tricky one to spot in its constellation, Cetus. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space. Back in the day, from 774 to 775, Earth got hit with a megablast of radiation. This crazy burst of energy left its mark. Tree rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast, but astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. Some folks think maybe a massive supernova caused the radiation blast. Scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars, or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So, it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells, and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants, sorry. Later on, they found this huge hole that was like 7 meters wide and nearly 20 meters deep, and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, These eerie craters have been showing up in specific spots in Siberia, where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments. And you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped in for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show, a bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech, because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty tough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 2,196 kilometers per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms like the Carrington event. And take notice. Imagine if a similar storm hit today, an internet apocalypse, anyone? Businesses would be sent offline, and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit? I guess it's no surprise that it's not that easy to just hop on a plane and literally fly to the South Pole, aka Antarctica. Sure, there are airports down there, but they're not really set up for commercial flights. So, most people go to Punta Arenas International Airport in southern Patagonia, Chile, and then take a boat if they want to see some penguins. But not only is it hard to fly there, it's even hard to fly over there. When you're cruising at 9,000 meters, you probably don't think much about what's happening below. But it's pretty unusual for flights to go directly over the South Pole, and planes flying across Antarctica are quite rare too. Technically, it is possible. I've already mentioned that there are airports there. But even so, the infrastructure down there is still super limited. There simply aren't enough airports or refueling stations to support regular commercial flights, making it tricky to operate in such a remote area. Plus, there are only a handful of specialized cargo and transport flights that go in and out, and they exist to cater to those few folks who actually live in Antarctica. Then, there's the weather that drives up the costs. The simplest example is that pilots there need special training, which costs money, which is all because of the weather. Another hurdle is something called ETOPS, Extended Twin Engine Operational Performance Standards. These rules dictate how far twin-engine planes can fly from an airport. Since there are so few airports in Antarctica, it's tough for pilots to stick to these regulations. Historically, ETOPS made it next to impossible to fly close to or over the South Pole. While flights over land have plenty of airports to choose from, Antarctica is a whole different ballgame. These days, some aircraft can fly up to 330 minutes, or, in rare cases, even 370 minutes from an airport. But even with those extended limits, certain parts of the airspace above Antarctica are still off limits. Still, in the grand scheme of things, that might not be a huge deal. The most curious of you must have Googled that already and found out that there really are Antarctic airways. Please, do not judge fast, and do not say I wasn't right saying how hard it was to fly to the South Pole. Let me break it down for you. Antarctic Airways advertise as the world's most exclusive transcontinental flight, but don't think you can just waltz in and book a ticket anytime. For starters, Antarctic Airways mostly operates flights to King George Island from December to March, so it's not all year round. But there are many more reasons why these flights are unique. If you dig into their website, you'll find you've got two choices: a full day in Antarctica or an overnight adventure. Prices kick off at $5,500 for a day trip and go up to $6,500 for an overnight stay. And if you're considering a private charter, get ready to shell out a pretty penny. Sure, that's a steep price compared to your average cruise ship crossing the Drake Passage, but here's the thing: it's about 20 times faster. A cruise ship takes 2 days from Chile, while Antarctic Airways gets you there in just 2 hours. Air travel to Antarctica is pretty limited, likely due to the high costs, limited seating, and the logistical challenges that come with flying to such a remote location. Plus, flights can often be delayed because of bad weather. Most travelers opt for a quick day trip or an overnight stay on King George Island, usually aboard smaller Beechcraft King Air 300 aircraft. The experience typically includes a stroll to a research station and a boat ride to see nearby penguin colonies, but that's just scratching the surface of what Antarctica has to offer. But once you're aboard Antarctic Airways, you'll see it's just like a regular flight on a smaller plane. You'll be served meals that have received some pretty good reviews. There are even photos floating around online showcasing the food, and honestly, it looks awesome! Those who've experienced it say it's luxurious yet unpretentious. You'll get a mix of meats and cheeses, plus treats like tiramisu, salmon salad, a single After Eight chocolate, and a selection of quality street candies. Today, everything may seem cool and safe, but back in the day, there were some pretty tragic events. On November 28, 1979, Air New Zealand Flight 901 tragically collided with Mount Erebus on Ross Island, Antarctica. Unfortunately, all 237 passengers and 20 crew members aboard lost their lives that day. Since 1977, Air New Zealand had been running regular sightseeing flights over Antarctica. This particular flight took off from Auckland Airport in the morning, with plans to spend several hours exploring the stunning Antarctic landscape before heading back to Auckland via Christchurch that evening. Initially, the inquiry into the incident pointed the finger at pilot error. However, growing public concern led to the establishment of a Royal Commission of Inquiry for a deeper investigation. The commission found that the crash had been primarily due to a change in the flight path coordinates made the night before, which the flight crew hadn't been informed about. As a result, instead of being guided by the computer down McMurdo Sound, as they were led to believe, the aircraft was mistakenly redirected toward Mount Erebus. In a way, this flight looks like modern one-day Antarctica tours. Flight 901 was marketed as a unique sightseeing adventure, complete with a knowledgeable Antarctic guide who highlighted various scenic spots and landmarks through the plane's public address system, while passengers enjoyed a low-altitude tour of McMurdo Sound. These flights operated as day trips, taking off from New Zealand and returning on the same day. The plane departed from Auckland International Airport at 8 a.m., aiming to land in Antarctica, with a scheduled return to Christchurch International Airport by 8 p.m. The total journey covered about 8,730 kilometers, including a 45-minute stop in Christchurch for refueling and crew changes, before completing the final 747 kilometers back to Auckland, arriving at 9 p.m. Back in November 1979, tickets for these flights were priced at $359 per person, which is over $2,150 in today's money. Anyway, this tragedy isn't the reason why planes don't fly over the South Pole. The real culprits are weather, ETOPS regulations, and of course, penguins. Yep, those cool and friendly little creatures. Friendly, at least according to researchers. With no natural predators on land, all of them are in the water, they're not really afraid of people and actually seem to enjoy our company. The South Pole is completely uninhabited and packed with penguins, making it pretty tricky to build anything down there. By the way, the North Pole actually allows planes to fly over it. Not too long ago, there were direct flights from Copenhagen to both LA and Tokyo, operated by SAS, and they cruised right over the North Pole. Other airlines joined in too. For example, Emirates ran a flight from Dubai to LA that took the same route. The difference in air traffic between the two poles mainly comes down to where people live and how much land there is. Roughly 88 to 90% of the world's population hangs out in the northern hemisphere, while only about 10 to 12% call the southern hemisphere home. Most folks in the south are clustered around the equator, in places like Indonesia, Central Africa, and Brazil. When it comes to flights heading to the South Pole, options are pretty limited. You mainly have routes connecting New Zealand and Australia, parts of southern South America, and a few spots in southern Africa, especially South Africa. There aren't really any direct flights over the South Pole, though some flights can get close to Antarctica. One possible route could connect Auckland, New Zealand to Cape Town, South Africa, but there aren't any scheduled flights for that right now. The few flights that come close to Antarctica are operated by Qantas and LATAM Airlines, linking Australia with Buenos Aires and Santiago de Chile. In 2021, Qantas took a long detour over parts of Antarctica on a flight from Buenos Aires to Darwin, and in July 2023, they adjusted a route closer to the continent to dodge some fierce headwinds on a trip from Santiago to Sydney. We also might have just stumbled upon the mother of all water reserves, floating in space, and it's been hiding under our noses for at least around 12 billion years. As for its size, it's hard even to imagine. 140 trillion times larger than all the oceans on our home planet combined. This cosmic water world is orbiting around a large black hole known as a quasar, located 12 billion light-years away. Quasars feature supermassive black holes, spewing out colossal quantities of radiation. This one in particular is estimated to be 20 billion times heavier than our Sun, and carrying energy that could outshine 1,000 trillion of them. Here, in our cozy Milky Way, we're used to seeing water in ice form. This water reserve in particular seems to be in the shape of vapors. The important thing about this discovery is that there may be water everywhere in the universe. We just need to learn where to look. You might be surprised to learn that not all stars are hot to the touch. We used to think all stars were like our Sun, these blazing hot balls of fire, ready to melt anything in their path. Their cooler counterparts are called brown dwarfs. What makes them special is that they're too small to pull off the nuclear fusion that keeps stars like our Sun shining. They don't give off much light or heat, which makes them hard to see. These brown dwarfs are also split into different categories. There's this one group called Y-type stars, and they're the coldest, with a surface temperature lower than your average cup of tea. If you could reach out and touch one, you'd probably just feel a cozy warmth. Around 4 billion years ago, Uranus apparently switched places with Neptune. It's hard to imagine planets that big doing that, but this theory might solve the mystery of how our solar system came to be. We know that rocky planets formed after big collisions. Take our planet, for instance. Around 4.6 billion years ago, things kept bumping into each other around the Sun until our watery Earth reached its final form. It also included one larger collision that blew up enough rock and gas for it to generate our moon. But when it comes to our larger solar system neighbors, Jupiter, Uranus, and Neptune, scientists still haven't got an answer. Standard models said it'd take forever for them to form, way longer than the solar system itself has been around. If this new theory is correct, it suggests that Uranus and Neptune came from this dense cloud of gas compacted around the Sun. Problem is, for the theory to make sense, they had to have swapped places at some point in history. Neptune is about 2.13 billion kilometers away, the farthest any planet can be in our solar system. Uranus is a bit closer, located at 3.5 billion kilometers. This new idea suggests that after they formed way closer to the Sun than they are today, their positions were altered. It could have either been because of many comets passing by over billions of years, slowly tugging the giant planets away. It's not a definitive answer to how gas giants were formed. It's more like a strong hunch, backed up by looking at a lot of numbers. Speaking of weird things found in our universe, what about this floating spoon that NASA's Curiosity rover took a picture of on Mars? As the machine was cruising around the red planet, it stumbled upon this oddly spoon-shaped rock during the summer of 2015. The rock has a handle and even throws shade on the ground. It's not a leftover utensil from some Martian picnic, but rather what NASA scientists call a ventifact. That means it's a rock that got sculpted by the wind. It's not the first time the Martian surface has delighted us with weird windy sculptures. There was the face on Mars, a rat, and even jelly donuts. It's also possible that diamonds are raining down on over 1,900 exoplanets out there in space. Scientists found out that you don't need particularly hot temperatures for carbon to turn into diamonds, like it was previously believed. Up until recently, we only knew of Neptune and Uranus to potentially feature sparkling showers. Astronomers were onto this interesting phenomenon for about 4 decades, but these planets were hard to study. We've only had one space mission, Voyager 2, swing by for a peek. A lot of progress is being made though, thanks to lab simulations. Neptune and Uranus are called the ice giants because their outer layers are filled with hydrogen, helium, water, and ammonia, what scientists call ice. And that gorgeous blue hue they have is due to the methane in their atmospheres. The beautiful diamondy phenomenon happens deep down, however. If we could visit, we would see that beneath the thick atmosphere, there are layers of very dense ice. And under all that pressure, chemical reactions are happening, possibly generating diamonds the size of a small town. We can't just dive into Neptune or Uranus with a diamond-seeking probe. Instead, the same conditions are being replicated in labs here on Earth, squeezing matter between diamond anvils and zapping it with lasers to mimic the extreme conditions. Under these circumstances, scientists managed to create artificial diamonds. Understanding how these rocks form down there could also explain why Neptune is hotter than it should be and why it's got such intense storms. These diamonds might also be the key to unlocking the mystery of Uranus and Neptune's weird magnetic fields. If we compare it to our planets, it doesn't behave the same way, so there may be weird things happening under the surface to affect the magnetism. NASA's plans include sending a new probe to Neptune or Uranus in the next decade. With the planets aligning just right in 2030, It's the perfect time to explore these potentially diamond-filled worlds up close. Planet Kepler 78b is another weird cosmic discovery. It's a hot, molten world that's doing laps around its star in record time, once every 8.5 hours, and pretty close, less than 1.6 million kilometers away. Hot environment aside, if we could set foot on its surface, we'd notice its sun being 80 times larger on its sky than the daily view we have here on Earth from our star. If we apply what we know so far about how planets form, this little guy shouldn't even be there. Specialists still don't have a clue how it came to be, or how it ended up where it is now. What we do know is that it will disappear soon. Sort of. Since it's so close to its start, this scorching, hot planet is going to collide with it in a couple of billion years. Sounds like a lot, but it's a cosmic jiffy. What's similar between our planet and Kepler 78b is the density. Sure, it's about 20% bigger than Earth and weighs almost double, but it's got that same solid interior. There's no possibility of it forming any closer to its star and simply moving away with time. It also couldn't have been born much further away and migrated in. Any movements inward would have been unstoppable, and it would have also collided with the star. This may not be a particularly groundbreaking discovery, but chances are you've never thought of it. There may be space dust in your hair right now. Every day, loads of outer space matter comes raining down on Earth. Sometimes we get flashy objects, like when a meteor turns into a meteorite by crashing down to the ground. But most of the time, it's quieter. This cosmic material drifts down through the atmosphere, landing softly as what we call space dust. It may not sound like much, but it does add up to around 14 tons every single day. This space dust contains tiny fragments of rock and metal, broken off from asteroids and comets during big collisions. These particles are very small. You can't see them without special tools, but every time you step outside, some of it might land in your hair. Shop pirate. Arr! Hold onto your telescope, space rat. Scientists have made an astonishing discovery. They've found the ancient heart of the Milky Way galaxy. But what is this ancient heart? And what does it tell us about the history of our galaxy? Let's find out. Catchunau retroskau, chatue puri say. Our success that years, chatis errors, I change site service. Bait shape visau, propay, should twice your ain't style. Pirate, is that it? Don, yes, and thank you, Captain Jack. Pirate, my pleasure. R, he leaves. That's right, on. What can I say? He's a space pirate. The Milky Way isn't just a candy bar, but a majestic spiral galaxy that's home to billions of stars, planets, and other celestial objects, and it's all spread out over a distance of about 100,000 light-years. The Milky Way has a distinct shape, with a central bulge and spiral arms that extend out from it, kind of like what I look like from the side. The spiral arms are like the suburbs, where the stars are more spread out, and the neighborhoods are quieter. They're made up of gas, dust, and stars that all move together in a circular pattern around the center. In between the spiral arms, there are vast regions of empty space, known as interstellar space. Here, you can find wispy clouds of gas and dust, as well as some of the most spectacular sights in the galaxy, like massive star-forming regions and colorful nebulas. The Milky Way is also surrounded by a huge halo of dark matter, a mysterious substance that we can't see but can feel its gravitational effects on the galaxy. This halo helps to hold the galaxy together, and it extends out much farther than the visible parts of the Milky Way. And finally, there's the center. Here, the most action happens. In the center of the Milky Way, there is a supermassive black hole, which is about 4 million times more massive than our Sun. Sagittarius, a star. This black hole is responsible for some of the most energetic events in the galaxy, like the emission of powerful jets of energy. Remember the famous first photo of a black hole that flew across the internet? It was Sagittarius, a star. We managed to capture this black hole because it's the closest one to us. All in all, the center of the Milky Way is full of stars that are tightly packed together, forming a dense cluster. And it was here that astronomers recently made a new epic discovery. The heart of our Milky Way galaxy has been found. And boy, oh boy, is it an old-timer. Hey, who are you calling an old-timer? A team of brilliant scientists has found a cluster of 18,000 stars, born right after the Big Bang. Together, they form the ancient nucleus of our Milky Way. These stars date back to a time when our galaxy was just a wee little baby, a mere collection of proto-galaxies, huddling together to form a bigger and better thing. The scientists called it the poor old heart of our Milky Way. Can you believe it? These ancient stars are over 12.5 billion years old. And yeah, maybe they account for a mere 0.2% of our galaxy's total mass. But that doesn't matter. These stars are the building blocks that formed the core around which all the other stars and planets took shape. But how exactly did they become this heart of the galaxy? How did they form? And how did we discover all that? To answer these questions, we'll have to plunge into the past. A very, very distant past. Once upon a time, almost 14 billion years ago, there was the Big Bang. Our universe was born. At first, it was incredibly hot, but as time passed, things started to cool down, and tiny pockets of gas began to clump together due to the force of gravity. These were the first galaxies. The Milky Way is one of these galaxies. It also started as a small clump of gas and dust, but over time, it began to take shape. The very first stars, protostars, began to form within the clouds, and their gravitational pull caused more stuff to come together. This process continued for millions of years until the Milky Way was formed. But to learn the history of our galaxy in more detail, we need to find these protostars. And this is far from an easy task. Researchers have discovered the ancient heart, using a neural network to analyze data from the European Space Agency's Gaia mission. The Gaia telescope is a space observatory launched by the European Space Agency in 2013. Its job is to map the position and movement of more than 1 billion stars in the Milky Way galaxy. 1 billion stars. That's like counting every grain of sand on a beach. It's a huge job, but Gaia is up to the task. So, how do they do it? The telescope has 2 cameras that take pictures of the sky at the same time. These cameras are so powerful that they can detect stars that are 1 million times fainter than those visible to the naked eye. Gaia takes many pictures of each star, and this allows it to track their movements with incredible precision. Thanks to the data collected by Gaia, astronomers are learning more about the structure and history of the Milky Way. They're discovering new details about the stars, including their ages, temperatures, and chemical compositions. Gaia is also helping astronomers search for exoplanets, or planets that orbit stars outside of our solar system. So, for this research, astronomers use Gaia and the most accurate 3D map of the Milky Way ever compiled. They had to analyze around 2 million stars to find the primordial group. One way that astronomers can determine the age of stars is by looking at its brightness and temperature. This way, they study a brief phase of stellar evolution known as subgiants. But imagine searching through the huge center of the Milky Way for the tiniest group of stars that are older than 12.5 billion years. This is like searching for a needle in a haystack. Luckily, they had a trump card up their sleeve: metals. You see, in the early universe, the cores of these stars were so hot and dense that they were able to smash atoms together to form heavier elements. These heavier elements are called metals in astronomy, even though they're not really metals like the ones we're used to. The more massive the star, the more metals it can create during its lifetime. When the life of the first stars came to an end, they made a big boom and scattered these metals all around. metals mixed with other gases and joined the newborn stars, and so on. As time passed and the universe got older, more and more generations of stars formed, each one richer in metals than the last. Can you guess what that means? The older the stars, the less metals they should have. So now it was time for some galactic archaeology. The team taught the AI to find the metal-poorest, most ancient stars, and it succeeded. It found a huge cluster, and all of them were within 30,000 light-years from the center of the Milky Way. Then, they separated out the stars that form the ancient heart from the stars that originated in a dwarf galaxy, and finally, we were left with the original stars around which the Milky Way grew. This discovery is incredible. It reveals the remnants of the Milky Way's earliest history. It turns out that simulations of the Milky Way's formation were spot on. The old stars existed just where they were predicted to be. Just imagine, the stars that remember our universe as a baby are still hanging out in the center of our galaxy. Isn't that mind-boggling? So why is this such a big deal? By studying these ancient stars, scientists have discovered some incredible things. For example, they've confirmed that the Milky Way's core began its life stationary and only picked up rotational speed